Yes. So last time we took time to understand what functions are and relations, where we used our table to actually approach this understanding using a practical approach, right? Then we try to find relation among the x values, among the y values, and then if possible among the between the x and y values. So today we want to take our time and understand what functions are because this is the big deal of this particular topic. So now, what are functions, right? Let's move away from this how do you call it, formal understanding or formal expecting this formal definition to actually understanding it practically too. So let's look at every machine that we have below. So you can name any machine that you have around, but the basic machine that I'm going to use, if you don't know it's a machine, I'm going to use a basic thing like calculator or your mobile phone. So if you take a calculator, like over the time, right, over our previous session, we use calculator when we are doing statistics. Then so let's do something simple like when you take a calculator, right, then you give it a particular thing, a small thing like 1 plus 2, right? When you press the enter key, you are going to have a particular result which is 3, right? So something is happening behind the scene. So this is what we put inside that machine, right? And the machine will give us this particular output, and then we use this output to whatever we want to do. So this one is what we enter, so values entered. So these are the values entered, let's call it like that. These are the values entered, and then this is the result from the operation. If the operation is going to be an error, it will say an error, right? Or let's say then we clean the calculator, right? We clean everything in the calculator, we do 2 times 3. The output that we'll have is what? 6, right? So these are simple values that we do. So these are the entered values. The entered values are this one, and this is the result again for this second case. So let's look at another machine like mobile phone, right? So on the mobile phone, when you touch, let's say touch screen mobile phone, the one with mobile, touch. So when you just touch it, you see that the machine is there expecting a particular action to be done on it before it will move, right? So when you have your mobile phone, you touch on the screen, right? The light comes on. When you want to make a call, you click on the call icon, then you get there, you enter the number, then you make the call, and they begin to do that operation for you. So you see that every time that the machine has to work, right, you need to actually do something. You need to actually give it a particular command, or you need to actually give it some values. You have to enter a particular value, and then it will take it and produce a particular result for you. So basically, all machines do that. No matter the machine that you may be thinking of, right? They all do one thing. They all take a particular input from the user, and then they give out an output, or they give out a result, right? So I'm using this term input and output because they are the ones that really functions are concerned with. So we are concerned with the input and concerned with the output. So a machine is like a machine, a function. So look at the machine as the function. Look at the machine as the function. So functions are machines, right? Machine, what they do, they take a set of input, do something to it, and give you a particular output based on what you want, right? That is what functions are in simple terms. So functions are machines, right? They are there, they are built in a particular way that they will take a particular set of input and then give you a particular set of output. Now it's not just any input that will go into every machine. For example, you can take calculator and say you are going to then, because it accepts any set of input, you are going to put water inside. No, it doesn't work like that. It's not every input that goes inside, but it's a particular set of inputs that goes inside. A set of input that goes inside. It's not everything that must enter that machine, right? And then if the value that you are putting inside is valid, that machine is designed for that particular value, it will take it, do some operation on it, and give you an output. So what you are doing, you just feed something inside and bring it out. You take your mobile phone, you can't just pour water inside and say it's accept any set of input. Every machine is designed in a way that it accept a set of input, a particular set of input. So those set of input are defined for that machine. So if you take your laptop to the same thing, right? Your laptop can browse and do all that. The calculator cannot do that. Calculator is not defined for browsing and those things and maybe downloading apps on it to be playing game on your calculators. But a mobile phone or a laptop can do all operation, can do browsing, can do everything because it is defined for that. But the calculator cannot do the browsing for you. So that's what machines are. So machines and functions, right? Functions are defined in a particular way to accept a set of inputs, do operation, and give you a particular set of outputs. Okay, so what we are going to do that every input that we put inside, every single input that we put inside, every value that we enter, right? We are going to call them X. x values. So we are going to call them x values. So these are the inputs. We call them inputs. And then we are going to have a particular set of outputs. Whenever you put any x inside, right, you are going to have a particular set of output called y value. So these are the outputs. So we are going to just name it by conventionally, or what people are using generally is y for output and x for input. That's what we use generally. So in the previous session we were seeing that thing like that, but I was saying x values and y values. But then normally these x values, we wanted to refer to them as the inputs, and the y values are our outputs. Okay, now if that's the case, then what are we driving to from this point? A function accepts a set of inputs called what? X values. Let's say x, and then give a particular y values, right? Based on an operation, and then based on our inputs, then based on our outputs, you use it for any other thing that you want to do. So basically, so far we have established that a function, right? We are going to compare it to a machine. So a function is a machine, but here is a mathematical machine, right? That accepts a set of inputs, but those set of inputs are defined input for that machine, because it's not every input that goes inside. So every set of input, right, is defined. And when the machine is able to accept that input, it will do a mathematical operation on it and give you an output. You are not concerned with the mathematical operation, but then with functions, right, we are going to see the full structure of what that particular equation is going to be. But first, let's try to get a basic definition of what a function is. Yeah, I've used most of the terms already. And I say functions are mathematical machines, right? That accept a set of defined inputs. Because it's not every input that goes inside, so but the input should be defined for that particular machine. That's why the term defined should be there. So functions are mathematical machines that accept a set of inputs. Let's call them x. So every input that we put inside, we call this x, to give a corresponding set of outputs, say y. Let's say call it y. The outputs are y through a mathematical operation. So we have to do an operation that will happen in the machine. The operation that happen in the machine is called, we call what? Mathematical operation. So this is the very basic definition of functions, right? Now, so with this understanding, let's look at another way of picturing, because all these things should be mathematics. So all of them should be mathematics, right? So we are going to approach this now in a mathematical way. Now, we say that when we have a particular input x, so we say x and we say y. And then, so let's say the calculator is here. Yeah, you have your calculator, and there are buttons here, buttons here, plenty, all of them here. Then the display option is here. So now, what will happen? Like, the calculator will not function on its own. The calculator is always waiting. It's ready, right? It has been defined. It can accept a set of defined inputs and do a particular output. But it doesn't do those things on its own. It has to wait for input to come. But the calculator doesn't know what inputs will come. So the inputs that are coming, that you are going to feed inside, it may vary. To the calculator, it may vary. It may be anything. It may be anything that will define, right? So it may be 2, it may be 3, it may be 5, it may be 7, it may be 1,000. So those inputs that you are putting inside, it may vary to the calculator, right? Because those values that you put inside are going to vary. Those inputs, right? We call them what? We represent them by a variable. So we represent them by variable. So x is actually not a number that you know. You and I don't know the number x. We don't know that number, but it is a placeholder. It is at the place of any input that you put inside. So because it is at the place of any input that you put inside, this is a variable. So this is a variable. Now, based on that variable, when you put that variable inside, for example, when you put the 2 plus 3 inside, we got 6, right? When you go to 2 plus 3, you have 5. When you have 2 times 3, you have what? 6, right? Now, so when you put a particular input inside, the same what's going to happen is the y also value. The y is the output. The output also change. So the output will also be varying. So it's also a variable. So the x and y are variables, right? Because the input will vary to the calculator, it will vary. The output will also vary correspondingly. Now, you see that the input that you are putting inside, based on the input you put inside, the y value, the y value, the value of the y or the output will vary according to what x is. So the y value will depend on what the x value will be. So the y value will depend on what the x value will be. So the y value will depend on the x value. The y value will depend on the x value. Meanwhile, the x is an input. It doesn't depend on anything. It has to wait for it. But it's the y value, that's the output. We wait for x value to come before it will what? Operate. Now, because of that, because the y will be depending on the x value, the type of variable that y is dependent variable. So we will call the y is actually a dependent variable. Why dependent variable? Because it is going to depend on an input dependent variable. So y is the dependent variable. So it's a specific type of variable it is. And then the y is what? The x is what? Definitely it will be what? Independent variable, because it doesn't depend on it. It doesn't depend on anything. It's the one that come in, and the y value will depend on the x value. So the output will depend on whatever you give to it. If you want to make a call, you call a particular person on your mobile phone, which is your machine. Yeah, based on the person you call, right? That's what the machine will respond to. So the machine has to wait for the independent variable, which is the x, the input, to come. Then based on that, the output will come in a particular way, in a particular direction, or in a particular pattern. So y is depending on the x. The y, which is the output, is depending on the input. So y is the dependent variable. Why is it variable? Because it can vary. Different outputs may come, different inputs may come, and different outputs may come, because they vary in the particular machine. But do you know that? But the buttons and those things are always constant. Those things are always constant on the machine. The buttons, the power button or whatever on your phone, they are always there. But then whatever the phone is waiting for is just your inputs, right? And your output will come vary. So those are things vary. Every other thing that is constant, every other thing that doesn't change is called constant to the machine. So mathematical way, right? An example of input, right? We can have an input. This is y, and output, right? Will be equal to, let's say, an input x plus 5. This is a simple example of a function. This is simple example of a function. So y is here, out here will be equal to whatever we put inside at the x plus 5. 5 is constant. 5 doesn't change. But the input x will always change. So this is an independent variable, and y is the dependent variable. The y value will be depend on what the x value is. So let's say if our x value is 3, right? If our x value is 3, so our y will be equal to 3 plus 5. This 5 doesn't change, so it's always 5. So if you have that, so y 3 plus 5 is going to be 8. You see that when x is equal to 3, right? When x is equal to 3, y is 8. Now let's show you another example of another case of showing you how the these variables change over time. So let's say our x is now, let's say our x is now 1. If x is 1, what happens to the y? So we have x plus 5, right? At the place of x, we just write 1 plus 5. Then what we have, y will be equal to 6. You see that when x changes, y changes, but then the y value depends on what x will come. So y is always waiting. So y is equal to anything that's x. Then depend on that, like we have the particular output. Let's try another example. Let's say x is equal to 5. When x is equal to 5, y will be equal to, at the place of x, you write 5 plus 5. So y is equal to 10. You see that this constant 5 does not change. It's constant. Just like the button on your calculator or on your phone, right? But these x are variable, so they can change. So if x is changing, right, based on the value of x, the y is changing correspondingly. So those are variable we call the change. They vary because they change, right? But then the y depend on the x input or the x value. So y is dependent variable. So it's depending on x, so it's dependent variable, and the x is the independent variable. This is a simple form of seeing the particular function that. So we have an input and a set of outputs. So I'll also write y is equal to 3x minus 5. So this is another example of a particular input. I can also write y is equal to x squared minus 5, or minus 6, minus 30, minus 74, whatever you want to put. But then once there is a dependent variable and an independent variable making a particular equation, then you have a function. But then most cases, you'll not be seeing us using y. So at the place of y, right, we can just call y like f function, right? We'll see that in the next operation, where we see the forms of notation of the notation of x. The notation of a function in different forms. So you can write in terms of y and then in terms of f of x. We'll see that in the next session. Thank you. I hope that you have understood this. And then let me just remind you of the definition of functions, which are mathematical machines that as a set of defined inputs, right? And we explain why it's a defined, right? To give a corresponding set of outputs, say y, through a mathematical operation. Mathematical operation always occur before we get a particular output. That's how simple it is. A function is a machine. Yeah. So see you in the next session, where we actually explore and continue on building these concepts.